This video tutorial will take a look at factoring difference of squares. The first polynomial we will factor is x squared minus 9. Of course, at first we must ask ourselves if there is a greatest common factor, which there is not. For a polynomial to be a difference of squares, it must be the difference, or a subtraction problem, of two terms that are squares. So this polynomial is subtraction, and both x squared and 9 are squares, meaning there is a number or a term that when multiplied by itself will result in x squared and 9. A difference of squares will factor like this: two binomials, one with addition and one with subtraction. The first term in each factor would be the square root of x squared, which is x, because x times x is x squared. The second term in each factor would be the square root of our second term, which is 9, which is 3, because 3 times 3 equals 9. So our two factors would be x plus 3 and x minus 3. Let's check for accuracy. X times x is x squared. X times minus 3 is minus 3x. Positive 3 times x is positive 3x. And positive 3 times negative 3 is negative 9. We know that negative 3x and positive 3x will cancel each other out, leaving x squared minus 9. So our factors check out. So x plus 3 and x minus 3 are our factors of x squared minus 9. Let's try another example, 4x squared minus 25. First, we determine that there is not a greatest common factor. Next, we can determine that this polynomial is a difference of squares, because it's the difference, subtraction, of two squares, 4x squared and 25. We know when factored, our difference of squares will look like this, with our first terms being the square root of 4x squared, which is 2x, because 2x times 2x is 4x squared. And our second term will be the square root of 25, which is 5, because 5 times 5 is 25. So we have our two factors, 2x plus 5 and 2x minus 5. Let's check for accuracy. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Positive 5 times 2x is positive 10x. And positive 5 times negative 5 is negative 25. We know that our middle terms, negative 10x and positive 10x, will cancel one another out, leaving us with 4x squared minus 25. So our factors check out. 2x plus 5 and 2x minus 5 are our factors of 4x squared minus 25. Let's try another example, 9a squared b squared minus 49c squared. This does not have a greatest common factor, so now we will determine if it's a difference of squares. This is a difference, subtraction, of two squares, because 9a squared b squared and 49c squared are squares. We know that a difference of squares factors as such, with the first term being the square root of 9a squared b squared, which is 3ab, because 3ab times 3ab is 9a squared b squared. And our second term in each factor is the square root of 49c squared, which is 7c, because 7c times 7c is 49c squared. So we have our two factors, 3ab plus 7c and 3ab minus 7c. Let's check for accuracy. 3ab times 3ab is 9a squared b squared. 3ab times minus 7c is minus 21abc. Positive 7c times 3ab is positive 21abc. And positive 7c times minus 7c is minus 49c squared. Our middle terms, negative 21abc and positive 21abc, cancel one another out, leaving us with 9a squared b squared minus 49c squared. So our factors check out. Let's do a quick recap. Our original polynomials, in black, are all difference of squares, because they are the difference, subtraction, of two squares. Factors of difference of squares shown in purple, will be a binomial times a binomial, where one of the binomials will be addition and the second binomial will be subtraction, as highlighted in red. The first term of each factor, as highlighted in red, will be the square root of the first term of the polynomial, also highlighted in red. And the second term in each polynomial, highlighted in red, will be the square root of the second term of the original polynomial, also highlighted in red.